Hello, my name is Nitin. Modern wireless devices are equipped with smart features that maximize communication performance while ensuring compliance with safety regulations. Various sensors are used to detect the proximity of the user to the phone and how it is being used. So, it can adjust its output power or switch antennas. These smart features need to be tested, which puts additional demands on exposure test procedures. Shpyag has developed powerful tools to test these smart features, including an application programming interface for the CSAR 3D, the most advanced vector measurement based specific absorption rate system, compliance with IEC 62209 3. The CSAR 3D API version 2 offers simple remote commands that can help users to quickly set up complex test sequences using only a few lines of code. It has first been developed for Shpyag's internal use, but a general, more powerful API was requested by several power users and manufacturers. In today's video, I will test features of API version 2 and demonstrate an implementation of a live measurement sequence using the API. The API server is responsible for interfacing with the user application on one side and the measurement hardware on the other side. The API option uses HTTP POST requests with JavaScript Object Network Arguments or JSON arguments and responses. This makes it independent of the operating system and compatible with a very broad range of programming and scripting languages. The server provides a modular interface, with each module providing commands for a given aspect of the overall process. Hardware Manager module reveals how to read out and set the hardware items. Measurement Manager module illustrates how to add configurations to the project and how to start a scan. The other modules are Communication Systems Manager, Post Process Manager, and the Project File Manager. A Jupyter Notebook based tutorial, which comes with the API version 2 installer, provides sample code snippets in Python for each of the modules, along with an overall example workflow of typical measurements. For example, this code snippet here performs a time average SAR measurement on LTE band 2. The tutorial contains code examples for setting up hardware, handling project files, performing measurements, and other common use cases. I will now demonstrate a measurement sequence that I programmed using the API version 2 in Python 3 or Python Qt. The test sequence consists of measuring the mobile phone SAR on LTE band 2 in the low, mid, and high channels, followed by time average SAR measurements at the channel with the maximum 1 gram SAR results. I select the required test case and hit the measure button. The custom application interacts with the API server to set up the measurement, and the measurement proceeds in a smooth manner. The results are updated to the application window along with the SAR distribution screenshots. The measured maximum occurs on the mid channel, and the test sequence continues with measurement of peak spatial time average SAR at this channel. We just have to enable the time averaging algorithm in the device. At the end, the measurement file is saved to the application directory. This simple custom application demonstrates the power of API. It can, of course, also be used to create more complex custom applications. One important use of this API is the possibility to implement CSAR 3D measurements in custom made Callbox software. Many test labs have developed their own base station simulator code used for setting the device and the base station subsystem in the required port. By having the CSAR 3D API, a SAR measurement can be automatically triggered in the right moment, bringing the lab automation to the next level. The API version 2 is a powerful extension to the measurement capabilities of CSAR 3D. It allows users to develop or implement custom test sequences that can be used, for example, to dynamically implement test reduction procedures, to automatically configure the device under test between two consecutive measurements for simple and reliable production line testing, measurement automation, including report generation, integration of SAR measurements with custom Callbox control software. The API extension is especially helpful for device manufacturers, test labs, and the regulators who want to quickly evaluate devices using custom test sequences. Thanks for watching this video.